मोस्ट वेलकम स्टूडेंट्स इन द मैथ रीथ अकेडमी। तो हम लोग आज इनडिटर्मिनेट फॉर्म पढ़ेंगे इन्फिनिटी अपॉन इन्फिनिटी, और उसको हम कैसे कैलकुलेट करते हैं बाय यूजिंग द एल हॉस्पिटल रूल। ओके, तो लेट्स स्टार्ट। टुडे वी विल डिस्कस अबाउट द फॉर्म इन्फिनिटी अपॉन इन्फिनिटी। तो इनडिटर्मिनेट फॉर्म इन्फिनिटी अपॉन इन्फिनिटी। Okay, so our limit is of the form infinity upon infinity. Then how we will calculate such limits, है ना? और उसका प्रोसेस हम देखेंगे. So we have a result, we have a theorem. We can also use L hospital rule here because 0.0 फॉर्म में हम लोग L hospital rule लगाते थे. It means take the derivative of the function numerator and denominator, then apply the limit. Okay, if we get the limit is non-zero, 0.0 फॉर्म नहीं बन रहा है और हमको एक लिमिट कैलकुलेट मिल जा रही है, तो वही हमारी लिमिट की वैल्यू हो जा रही थी। ओके, तो इस फॉर्म में भी हम ये जो रूल है, ये जो डेरिवेटिव वाला रूल है, वो हम अप्लाई कर सकते हैं। कैसे? लेट अस सी। सो वी हैव द रिजल्ट if the limit, we can just set limit x tending to a of fx and the limit of x tending to a of gx, both are infinity or both infinite. Infinite, then what we get? Then the limit x tending to a of fx upon gx is just equal to f dash of a, and this is your d dash, provided this is f dash of a it's not equals to 0, and this is not equals to f dash of g dash of, ओके, वो जीरो नहीं होगा, तो उस केस में हम इस लिमिट को डेरिवेटिव के फॉर्म में लिख सकते हैं इफ दिस फॉर्म बी गेट। ओके, सो प्रोवाइडेड, यू कैन से प्रोवाइडेड द राइट हैंड लिमिट नॉन इंडिटरमिनेट फॉर्म, यू कैन जस्ट राइट provided the right hand side is itself not indeterminate form. Okay, so let us see how it will be exist. It means we are going for the proof of this. Okay, so let's write the proof. So you know that if we have taken this effects upon gx, so you can have easily, you can write like this. This is 1 upon f, 1 upon gx divided by this is 1 upon fx. You can write like this in a such a way, because gx is tending to infinity. When x is tending to a, so it means you get 1 upon infinity type, and this is also 1 upon infinity type. Then you can easily say this is of the form, this is of the form 0 upon 0 at x tending to a. So we already know about कि अगर 0.0 फॉर्म होता है then we can apply DL hospital rule. Okay, तो यहाँ पर हमारे पास जो राइट हैंड साइड एक्सप्रेशन है, इसमें हम DL hospital rule अप्लाई कर सकते हैं. तो if we apply the rule, so using DL hospital rule here, because it's a 0.0 form, so what we get? We get this limit x tending to a of this is fx upon gx. When we take the derivative of it, it will be equal to this is limit x tending to a and take the derivative of this expression. So you will have this is g dash of x divided by gx whole square and divided by this is f dash of x upon this is fx whole of it. So if you are simplify, you will get what limit x tending to a. ये fx ऊपर चला जाएगा तो you will have fx upon gx whole of square into this is g dash x upon this is f dash of. Okay, so we will get this expression. Okay, you are taking this is equation number 1. I'm just taking this equation number 1. Okay, तो अब हमारे पास जो एक्सप्रेशन है दिस वन एफ एक्स अपॉन जी एक्स का होल स्क्वायर, इसके ऊपर हमारे पास चीजें निर्भर करती हैं कि ये वैल्यू क्या कैलकुलेट होके आ रहा है. ठीक है, सो वी हैव जस्ट टेकन, so now let if I'm taking this is the limit of this is limit x tending to a, this is your fx upon gx is something some a. Okay, so अब ये कुछ भी हो सकती है, it's finite, infinite, whatever we get this limit. So I'm just taking this is the some a in anyhow, और हर cases को हम discuss करेंगे बारी बारी से. So the following cases arises. What are the cases? So case first. If I'm just taking a is a non-zero number and it's a finite number. Okay, so when a is a non-zero number, when a is, we don't know what is a. अगर हमें a पता ही होता तो हम because you know that is your infinity upon infinity form. But if you get the limit, what is the limit? It's a finite non-zero limit, or it's the infinite limit. In other cases we will discuss. Okay, so first we consider that a is a non-zero number and a is a finite. It's something a is finite non-zero number. So non-zero finite है. अब अच्छा थोड़ी देर के लिए अगर हम देखें तो you can, if you are dividing this whole expression, now what will be the expression? Looks like this, fx upon gx, you can just say from 1 we can easily say this is your a is just equal to this is what, this is your a square into this is the limit x tending to a, or this is g dash of x divided by f dash. Okay, it looks like this. If you are dividing whole expression by a square, okay, so on dividing both sides, by a square. तो अगर मैं स्क्वायर से डिवाइड करते हैं तो व्हाट यू गेट फ्रॉम हियर, यू गेट 1 अपॉन a, बिकॉज a इज अ नॉन जीरो नंबर, देन यू कैन इजीली डिवाइड बाय a square. So it will be equal to 1 upon a, and this will be get limit x tending to a, and this is your g dash x upon this is f dash of x. Okay, you have this. If you are because 1 upon a is this, then a will be what? A is just equal to limit, will we take the reciprocal of it, this is a, and this is f dash of x divided by g dash of x. Okay, so what was the a क्या था? Limit of fx upon gx, है ना, यही तो था. So this implies you will get this is limit x tending to a, and this is your fx upon gx is just equal to limit x tending to a, this is your fx upon gx. Okay, so the first case is done when a is non-zero and a is a finite number, then this rule is followed. You can take the derivatives and you can apply the limits. Okay, so limit of fx upon gx will be equal to limit of f dash x upon g dash x. Okay, Let's discuss about the second case when a is the 0. Second. So when a is just equal to 0. So clearly if a is 0, then a plus 1 will be non-zero. So in this case, you can take, in this case, this is a plus 1 is not equals to 0. Okay. So if we are just taking in such a way, we have, एक चीज ध्यान दीजिएगा, if I am taking a plus 1, what touch a, you can have limit extending to a, and this is your fx upon b, and this is plus of 1. And you know that in the 1, you can easily write like this, limit extending to a, because here there no x, it's a constant value. So you can easily like this is fx upon gx and plus of 1. Okay. And now you can just apply the limit extending to a on taking the LCM. So you will have fx plus gx divided by gx. Okay. And you know that this expression have a non-zero. तो अगर ये expression non-zero value रखता है, तो we can apply the previous case, है ना? Previous case को हम apply कर सकते हैं, which is of, you can say, this is of the form infinity upon infinity form. Okay. So you can apply the derivative on this right hand side. So you can easily see this is limit x tending to a. This is your f dash x plus g dash x divided by g dash x. Okay. And this you can say by the case first. Because we फर्स्ट केस में हम ये चीज प्रूव कर चुके हैं कि अगर a is a non-zero number, then you can easily apply the derivative rule, या you can say the L'Hospital rule. So अगर हमारे पास ये मिलता है, तो you can easily divide by g dash x, और न्यूमरेटर को हम डिवाइड कर सकते हैं g dash x, तो हमको फिर से रिमेन्स हो जाएगा f dash x upon g dash x, and this is plus of 1. Okay, and already we have, this is a plus 1. So you can cancel this 1 with 1. So you will get what? This is a is equals to limit x tending to a. This is your f dash x divided by. So अगर हमारे पास a की वैल्यू 0 भी आ रही है, तो उस केस में हम डेरिवेटिव वाला रूल अप्लाई कर सकते हैं. So you can just have a limit x tending to a. This is your fx upon gx is just equal to limit x tending to a. This is your f dash x upon g dash. Okay. तो ये केस भी हमारे पास कंप्लीट हो गया कि if we getting the limit 0, in that case we can also apply the derivative rule. Okay. And what will happen when a is infinity? क्या हम infinity के केस में ये चीज अप्लाई कर सकते हैं, उसको भी डिस्कस कर लेते हैं. Case third, when a is just equal to, when this a is just equal to infinite. So in this case we can take the reciprocal, because reciprocal will be equal to 0, और हम 0 का केस पढ़ ही चुके हैं. So if you are just having a limit of this x tending to a, and this is your fx upon gx. Okay, and now it is equal to 0. If you are taking the reciprocal, you can have this limit x tending to a of gx upon fx. Okay, and if it is infinity, then it will be equal to 0. If it is equal to 0, we can apply the previous second case. Okay, क्योंकि लिमिट अगर 0 होती है तो उस केस में डेरिवेटिव वाला रूल हम लगा सकते हैं. तो it will have looks like limit x tending to a, this is equal to g dash x divided by f dash. Okay, you can say by the case second. बहुत इजी था ये तो हमारे पास बहुत इजी था. तो you know that, and it was what? This is 1 upon a, you can say. It looks like this, huh? And this is limit x tending to a is just equal to g dash x divided by f dash x. Okay, and that will be equal to, easily you can say this is a is nothing, this is limit x tending to a, this is f dash x divided by g dash x. तो अगर इनफाइनाइट भी हमारे पास लिमिट की वैल्यू आ रही है, दैट इज आल्सो ओके, एंड वी कैन एप्लाई टू अप्लाई द एल हॉस्पिटल रूल और डेरिवेटिव. ओके, so this is, you can say, limit x tending to a, fx upon gx is just equal to limit x tending to a, f dash x divided by g dash. Okay, so this is done. In each and every case, we can say if the limit is of the form infinity upon infinity, you can also apply the derivative. So this implies if this limit x tending to a of fx upon gx is of form infinity upon infinity, we can apply this rule. This is limit x tending to a, fx upon gx will be equal to its derivative. Limit x tending to a, this is your f dash x upon g dash. Clear? So hope so. You can the DOL hospital rule was given by 0.0 form, and we can use 0.0 form. Furthering we proved कि infinity upon infinity form भी अगर होगा, then we can also apply the L hospital rule, you can say. Yeah, you can say derivative rule we can apply here, f dash x upon g dash. Okay, so hope so कि ये proof आपको समझ में आया होगा. Whatever the a, that is 0, or it is a finite non-zero number, or it is a infinite, then in each and every case we can able to apply the DL hospital rule for infinity upon infinity form as well. Okay, so two cases we have discussed, two indeterminate form. One is 0.0 form. In a 0.0 form, we already proved that we can apply the DL hospital rule easily, but in infinity upon infinity form we can also apply. Okay, so in the next, let's discuss one example here. So we have one example. Let's discuss one example here. They asking about evaluate. It was the example number 2 from your textbook. Evaluate, this is limit x tending to 1, and this is a log of 1 minus x divided by cot phi x. Okay, so you know that cot phi x is just equal to cos pi x and divided by sin pi. When you are tending x, this will be tending to infinity when x is tending to 1, because cos pi is just equal to 0 and sin pi is just equal to 0 and cos pi is just equal to minus 1. So it will be equal to infinity. Next we will talk about this is log 1 minus x. It will be also tending to infinity when this 1 is tending to x is tending to 1. So you can also, when you are going to write the solution, you can write here, since this limit is of the infinity upon infinity. Since this is limit x tending to 1, and this is log of 1 minus x divided by cot upon phi x is of the form infinity upon infinity. We can apply the DL hospital rule. Okay, so we can take the derivative. So this is limit x tending to 1. तो यू कैन अप्लाई द डेरिवेटिव। तो लॉग का डेरिवेटिव क्या होता है, डी डी एक्स ऑफ, दिस इज लॉग ऑफ वन माइनस एक्स, इट विल बी इक्वल टू, लॉग का होता है वन अपॉन एक्स, इट विल बी वन, वन माइनस एक्स, फिर वन माइनस एक्स का हो जाएगा माइनस का वन, तो इट विल बी इक्वल टू माइनस वन अपॉन वन माइनस एक्स। दिस इज द डेरिवेटिव ऑफ लॉग एक्स। व्हाट इज द डेरिवेटिव ऑफ द कॉट पाई एक्स? तो यू नो दैट कॉट का होता है माइनस का कॉसेक स्क्वायर पाई एक्स इंटू पाई। ओके, so you will get here, take the derivative, so it will be minus 1 upon 1 minus x, ये हो गया, divided by this is minus of pi, and this is of cosec square pi of x. You just take the derivative. आप सभी लोग इंटरमीडिएट में पढ़ चुके हैं डिफरेंशिएशन ऑफ अ फंक्शन। ओके, so this is a by the rule D or L hospital. Okay, so by this we can apply this thing. Okay, so minus minus cancel हो जाएगा, you will have what, limit x tending to 1, cos x को ऊपर भेज सकते हैं, तो it will be sin square pi x, okay, and divided by 1 minus. When you apply this x is equals tending to 1, then 1 minus x will be tending to 0, and sin is also will be tending to 0. So this is now 0.04. And you again apply the L hospital rule before the 0.0 form, you know that. Okay, so you can again apply this limit x tending to 1. You apply this, this will be, take the derivative of sin square pi x, it will be 2 sin pi x, and sin का हो जाएगा cos pi x, and pi x का हो जाएगा pi is remaining. And you check, when you apply the limit, they take the derivative of this, it will be equal to minus. Okay, so you can also, you can say by TL hospital rule. You will have to mention कि आप किस रूल किस मेथड से डेरिवेटिव ले रहे हैं। ओके, तो दिस बाय द एल हॉस्पिटल। तो अगर हम यहाँ पर, अब यहाँ पर हम x बराबर अगर 1 पुट करते हैं, तो यू विल गेट 0 है। ओके, वट एवर यू विल गेट द 0 है। already I was with this pi, यहाँ पर pi था यहाँ पर, so this pi is remaining here. Okay, you can just have 1 upon pi is here, so you just take it, cancel pi, this is pi, and what is remains, it will be negative of this limit x tending to 1, we are taking two constant is outside, minus 2, this will be sine of pi x, and this is cos of pi x. When you apply the limit, you will get minus 2, and this is, you have sine of pi, and this is cos of pi, because this is equal to 0, so this whole thing will be equal to 0. So this limit becomes 0. This limit will be equal to 0. So by using the TL hospital rule, we can able to find its limit easily. तो आपको देखना क्या होगा, यू विल हैव टू चेक इट इज अ इनडिटरमिनेट फॉर्म और नॉट। अगर ये इनडिटरमिनेट फॉर्म है, देन यू कैन अप्लाई सच केसेस, और अगर नहीं है, देन आपका जो भी मेथड है, जो लेफ्ट हैंड लेफ्ट हैंड लिमिट राइट हैंड लिमिट उसको निकालना, उसको देखना वो एग्जिस्ट कर रहा है कि नहीं। एंड नेक्स्ट यू कैन अप्लाई सच टेक्निक्स टू कैलकुलेट द लिमिट। तो प्रीवियस लेक्चर्स में हम लोग पढ़ चुके हैं, बट अभी हम वो एक कुछ स्पेशल फॉर्म्स पढ़ रहे हैं जिनको हम कैलकुलेट करते हैं बाय यूजिंग द टीएल हॉस्पिटल। तो इजिली एक सवाल आपका रहता ही रहता है आपके क्वेश्चन पेपर के अंदर, तो आप इजिली इस प्रॉब्लम को कर पाते हैं। ओके, तो आई होप सो कि आपको समझ में आया होगा। एक और क्वेश्चन हम कर सकते हैं। ओके, नेक्स्ट नेक्स्ट हम जब एक्सरसाइजेस सॉल्व करेंगे, तब उसमें हम बता देंगे और कुछ प्रॉब्लम। ओके, तो मिलते हैं नेक्स्ट लेक्चर में, और नेक्स्ट इंडिटरमिनेट फॉर्म के साथ। ये हमारे पास अभी तो हम नेक्स्ट एक्सरसाइज को भी डिस्कस करेंगे, तो एक एक प्रॉब्लम को हम कराएंगे। तो यू आर बी कनेक्टेड, आप लर्न करते रहिए, सीखते रहिए, और शेयर भी करते रहिए और भी स्टूडेंट के पास लेक्चर। थैंक यू सो मच।